Welcome back all. So today we're going to go ahead and try out our crunch and air crack and see how well they work with one another. And you will soon realize that if the password is of a certain length with the CPU, even the fastest of the CPUs, it's going to take forever. Also, if you would like to monitor the temperatures of your CPU, type in as root, type in DNF install X sensors. Is it? Let's just have a look at it. Yes. DNF install X sensors, and then you can just start it as a non-root user with this command. Or you can just find it in the start place. So X sensors, and then just start it up from there. Also, another interesting thing is to install H top, which will allow you to monitor in real time the usage of your CPU cores, or threads, as they are called. So you can see that they're pretty not busy at the moment. They're not really busy at the moment. They're not really doing anything. And the temperature at the moment is, well, it's fairly low, but it's pretty warm here at the moment. So that might have an effect. But in any case, let's go ahead and start this process. So I have constructed this command here for you, but let me just copy this part out and I'm gonna rewrite the rest. So first off, make sure that you are in the directory, or that you at least know where your charge set is located, because we're going to be utilizing it. And if I type in crunch, and there are certain rules which you can apply just by thinking about it. What sort of a password would somebody have for a wireless? Well, to begin with, it cannot be shorter than 8 characters. Generally speaking, I think that the general standard for VPA2 passwords is 8 characters. And if you come to think about it, who on this planet Earth would actually go to the password length of 20 characters? Because take a look at what happens with 20 characters and how many possible combinations there are. A charge set mix cat. Am I in the right folder here? No, I'm not. Okay, let's go ahead and let me just swap these two folders. So cd cd. Nope, I need to be in the wireless, and there you go. And this one actually needs to be in crunch. Okay, so these are just places on the file systems that I'm navigating on. I've taught you how to navigate on your file system. I've just created a new folder for wireless where I have placed all these files, and I've created one of my own, which is test. These are just small notes which I have, and these are some of the rules that can be applied. So the first rule that you can apply is that you don't want any duplicate letters. Usually it goes numbers then letters. This is basically 70% of passwords out there for wireless. No smaller than 8, and I purely doubt that it's going to be longer than 16. Okay, you can also state that you don't want any capital letters in the middle. Only the first letter can be capital, which is kind of dodgy. Wouldn't recommend that. Or you can state that the first 4 chars are letters. You can see we'll be able to customize these things on our own. So if I type in crunch again, and if I specify something crazy like this, that the length of the password is 20, the first number is the minimum size, and the second number represents the maximum size. So you can alternate between these two. You can say from 8 to 20, and then you can use -f for file, and well, you can specify the full path to it. char set. This is where I have extracted the crunch, and this is probably where you have extracted it as well. And let me just go ahead and see the name of the list that I wish to use. I want to use mixed alpha numeric, meaning capital, lowercase letters, and numbers. And I don't want to use a space. Come on, where is it? There we go. Mixed alpha numeric. So you paste it in like this, and you need to specify a path to your character set. So let's press enter and press Ctrl C immediately. And this is crazy. It says that it would generate 8,321 petabytes. This is how many lines you would get. It would take you an eternity of time to crack this with a CPU. Here, let me just help you out with the calculations, and I hope that my math is right here. Let's use a calculator. And let's use this number, even if okay, I can't really copy it. So let's just write it down. So it's 8530547925792579252 672. Okay, so this is a huge number. And I think that my processor can go about 10,000 key combinations per a second. Okay, so let's divide this number with 10,000. And you still get a fairly large number. This is the E is just the way that it's enumerated. But if you have E here, it's a lot. And let's go ahead and divide that. Let's go ahead and divide that number with the amount of seconds in an hour. So an hour has 3,600 seconds. So this is how many hours it would take you to crack this password. Okay, let's divide this by 24 because a day has 24 hours. Oh, that's a lot of days there. Okay, let's divide this by 30 because a month has 30 days. Still a fairly large number. And now let's divide this by 12 because a year has 12 months. Okay, granted, not every month has 30 days, but doesn't matter for this calculation. It would need about 2 million years. Well, closer to 3 million years. Yeah, that's not going to happen. So you either need a greater amount of combinations, greater amount of keys tested per a second, or you need better filters to actually have a lower key base, a lower amount of keys. So the first thing that we're going to do is narrow this down. I'm going to type in 8 to 13. My password is 13 characters long. It's basically test 1, 2, 3, 4, 5, 6, 7, 8, 9. Actually, a dictionary attack would work better against my password that I've set for this tutorial practice. But it doesn't matter. It's just for learning purposes anyway. So let me just do a demo here. It's still going to be fairly large. Okay, press enter and okay, so we are still at the same number of lines. So from 8 to 20, probably couldn't even calculate that amount, but let's just, let me just do this. So let's say from 8 to 8, the length of the password is 8. Okay, so you see this here is 8,321 and here it's 1. Petabyte is huge. It's like 1,000 terabytes, which is 1,000 gigabytes. It's huge. 8,000 petabytes, that's like a data center, maybe, best case scenario. And now this number is significantly lesser if the amount of characters is minimum, which is 8. Okay, let's do a calculation here. Let's see if we can actually get some meaningful results here. So let's divide this by 10,000 and state that that's equal. Okay, I still have a very large number here. Let's divide that by the amount of seconds in an hour. So 6 million hours divided by 24 4 divided by 30 and divided by 12. Yeah, this is not gonna work. My apologies, you wouldn't require actually 2 million years. You would need to divide 2,700,000 with 365 to get the amount of years. But you get the idea, it's still like pretty large number. So 701 month divided by 365. Okay, so in 2 years, you would be able to crack this. Basically, it's not a realistic amount of time that somebody could invest. But if I do something like this, let's see what happens. If I state that I don't want the uppercase letters to actually repeat, so, or let's say lowercase, doesn't matter. Let's say that the lowercase letters are in a non-repeatance mode. Okay, so I do get a smaller number, but not by that much. Still, we are facing some serious problems here. And that's not going to, I mean, it's going to work. You're going to be able to crack things, but it's just going to take you a hilarious amount of time, which is not a realistic option for us. So let's use something else. Let's use the -t option. So the -t option allows you to customize the individual fields of the password. So because I know that my passkey is 13 characters long, you can use an educated guess and you can do separate attempts for separate lengths. So you can state, okay, I want length 1313. I want length of 8 characters. I want length of 9 characters. I want length of, I don't know, 10 characters or something like that. And then you can, in the -t option, you can specify a pattern. And you can also do multiple attempts on multiple patterns. So what could the password be? And if I just open up this and clear the screen and type in man crunch /-t, it should be here somewhere. Okay, with the -t option, you can actually specify what sort of characters will be inserted in where specifically. So you can say that basically will be a placeholder for lowercase letters, comma will be a placeholder for the uppercase letters, percentage sign will insert numbers, and the caret sign will insert symbols. So let's just make attempts with pure guesswork. You can safely conclude that the first several characters will actually be letters. Most of the wireless passwords have first characters as letters. And most of the passwords are between 8 and 16 digits long. 13, maybe some golden middle, something like that, but most of them are between 8 and 16, by my estimates anyway. I've seen a lot of them, and we've done some analysis, and that's what I came up with. It doesn't need to be correct, but that's what I came up with anyway. So you can assume that the first characters are actually letters, and you can have two sets. So one set can be the first letter is the uppercase, and that the second set is that the first letter is lowercase, because usually people just have first letter as an uppercase and they don't have any other uppercase letters. Another thing that you can do is when your ISP provider comes and hooks you up with the internet connection, they usually have a default wireless password on the routers. You can check it out and you can see the pattern that they are using. For example, my ISP provider, when they plugged into Wi-Fi, the default password was something completely random, which was good, but there was a major flaw in it. It contained only capital letters, and it was of a certain length, and all the default wireless passwords were of that length, and they all contained capital letters, which is a huge problem. A huge problem, because that reduces the number of combinations drastically. So let's go ahead and make our own pattern here. Okay, so I'm just gonna go ahead and say that the first four characters are letters, and this usually is the case. If you think about the names of people and places, they're all going to, the bare minimum will be 3 letters. I'm just, for the sake of convenience, I'm going to use 4 here. But usually the very first 3 characters will actually be letters. And then the rest are usually numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is one pattern. At is a placeholder for lowercase letters, and a percentage sign is a placeholder for uppercase letters. And I would not like the lowercase letters to be repeated more than once. You can set the repeatance pattern here. There is no need for the repeatance pattern to be longer than 2 ever, in my opinion. Generally, people don't have it. If they're using a name or something like that, they're gonna have, their names can contain 2 repeating letters and no more. But now we actually reduce the size of the pattern, but have we reduced it enough? Not really. So this is, let me just compare this one. I Control-Shift-C, Control-Shift-V, and let's go ahead and compare this one. Control-Shift-C and Control-Shift-V. So, oh, have I made a mistake here of some sort? Oh, this was from 8.8. Okay, so let me just show you. I can't really. I need to go up. 8.13. Okay, so you can just compare it to this number. And so this number is definitely a lot bigger than this one. But this one doesn't help us. If we divide this by 10,000, just subtract 4 places. So 1, 2, 3, 4. We're still left with this amount of seconds. And I'm going to go ahead and subtract 2 more places for division by 1,000. And then it would be left with this number, this divided by 3. So this number of hours, which is still quite a lot, but it's significantly less from before. So now what we can do, we can actually, instead of these placeholders, we can actually insert our own letters and numbers. So if I do this, I get a more reasonable amount of lines. But as long as it's in terms of petabytes, this is going to be huge. Okay, so this is 179 terabytes, but you get the idea. And if I do this, yep, it's 17 terabytes now, so it's significantly less, and it just keeps on reducing in size the more places you know. So even if you know a fraction of a password, or even if you know its length, that's going to reduce the amount of possible combinations significantly. Okay, so we're going to pick up in the follow-up tutorial because I'm running a little bit short in terms of time.